Hi, the SI meteorologist Paul Doreen here with a brief discussion on the North Atlantic Oscillation, otherwise known as the NAO. In other videos, we've talked about Pacific Ocean features, such as short-term tropical Pacific features that reflect whether it's warmer than normal or colder than normal in the Pacific Ocean around the equator, otherwise known as the El Nino or La Nina. We've also talked in another video about a long-term, larger-scale Pacific Ocean feature called the Pacific Decadal Oscillation, or PDO. Well, the Atlantic Ocean has its own features. One such feature takes place in the North Atlantic region, and we'll get into the definition of that right now. It's a climatic phenomenon in the North Atlantic that involves the change in pressure between a climatic low over Iceland, otherwise known as the polar low, and a climatic subtropical high that's usually situated over the Azores island chain in the eastern part of the Atlantic. The change in pressure between the low and the high dictate this North Atlantic Oscillation Index, and it causes a change from positive to negative, which in turn affects the weather, especially the wintertime weather here in the Mid-Atlantic region of the northeastern part of the U.S. Through these east to west oscillations of that low and the high, the NAO controls the strength of the westerly winds, and that in turn dictates where North Atlantic storms go, whether they move west to east or buckle more and drop, let's say, from the northwest to the southeast across the North Atlantic. And all of that has an effect on the Mid-Atlantic wintertime weather situation. Now, the NAO is not quite as predictable or, let's say, as well behaved as some of those Pacific Ocean features. It tends to vary quite a bit. However, once in a while it does last in the same sign phase, either positive or negative, for several months at a time. And let's say you're in a negative phase of the NAO, you may have several months of cold and snowy conditions if it happens to be wintertime in the Mid-Atlantic region. As far as those indexes go, the positive index and the negative index, let's take a look at the description of these indexes and what kind of effect it has on the weather. When the NAO index is positive, that insinuates that there's a stronger than normal high pressure system over the Azores, a subtropical high, and also a stronger or deeper than normal Icelandic low. This increases the pressure gradient in the North Atlantic, and what that does is cause the westerlies to increase in strength, and that causes storms to move on a more northerly track in the North Atlantic. And the bottom line, when the index is positive as far as the NAO is concerned, those increased westerly winds allow the cold air to move pretty much on a west to east off the North American continent, rather than letting it build up and dropping south into the northeastern part of the U.S. Now, conversely, if there's a negative NAO index, the subtropical high and the Icelandic low are weaker than normal, and this decreases the pressure gradient across the North Atlantic. And ultimately what this does, it allows very cold air to build up in the eastern part of Canada, let's say, and Greenland, and drop to the south into the northeastern part of the U.S. So again, during the wintertime, when the NAO index is negative, that gives you the possibility of cold and snowy weather here in the Mid-Atlantic region. I'd like to now take a look at some graphics that kind of better describe the NAO. The first one will be a graphical representation of the NAO during both the positive and negative phase. This is from a NOAA website, and we'll look at the index since 1950 as well as the current index to see what's going on right now in the North Atlantic. Well, here's a graphical representation from NOAA when the NAO is positive. This on the left is the upper air pattern of the 500 millibar height anomalies. And notice along the east coast of the United States, the average heights are above normal over the eastern U.S. and the western part of the Atlantic. And this translates over here on the right to surface temperature anomalies that are basically higher than normal, less snow than normal during the wintertime. Above average temperatures are seen across the eastern U.S. when the North Atlantic Oscillation is in a positive phase. Now let's take a look at a graphical representation of the negative phase, and here again we have the upper air pattern of the 500 millibar height anomalies during a negative NAO here. And notice over Greenland and the eastern part of Canada we have above average heights. Basically this leads to the possibility of cold air from really developing in eastern part of Canada, and ultimately that can drop into the northeastern part of the U.S. Over here on the right we have the temperature pattern, below average temperatures basically throughout the north central part of the U.S. and all the way into the eastern part in a negative NAO phase situation. This is often called a high latitude blocking pattern that's sometimes developed when you have a negative NAO. What typically happens, you may have a large-scale high-pressure system that's kind of stuck over Greenland, and that shoots down wave after wave of cold air masses, colder than normal, into the eastern part of the U.S. So if you love snow, then the NAO phase that you want during the wintertime is negative for the Mid-Atlantic region of the U.S. Now, NOAA keeps a running index table here of the index from 1950. That's what we're looking at right here. A couple things I want to point out. As I mentioned earlier, this particular feature in the North Atlantic is not quite as well behaved, let's say, as the Pacific Ocean features. It oftentimes will bounce back and forth. Here, for example, in the 1997 time period, you could see it just went back and forth from positive, negative, positive, negative, positive, negative. However, there are periods, including like right here in the early part of 2010, where it may stay the same sign for several months. So this thing, even though it is quite variable, oftentimes from season to season and from year to year, can stay in the same kind of phase for several months at a time. And if it's negative, for example, that's when you could have a cold and snowy winter here in the Mid-Atlantic region. So this is one of the things, one of the ways to track what's going on. Let's now take a look at the current conditions. Here is the current condition for the NAO from a NOAA website. And again, this actually goes back to February, and here we are, February, March, April, all the way into the early part of June. Right now, the NAO is just around zero, kind of a neutral signal, and you can see how it's bounced back and forth, but generally has been positive over the last few months. Now, a little bit lower here, we have a 7-day forecast and a 10-day forecast, and again, these things go out about 10 to 14 days. It's not a highly predictable feature, but it's something that is very important to watch. This particular situation here in early June 2011, the prediction from some of these models that NOAA runs is for the NAO to drop down into the negative phase and actually get quite a bit below zero, down to about -2 in about 10 days or so. Now, especially during the winter time, this is a very important feature to watch. Again, a negative NAO during the wintertime often leads to cold and snowy conditions here in the Mid-Atlantic region. So that's it for now. I'm the SI meteorologist, Paul Dorian.